Welcome to Module 22, Implementing Operational Procedures. This module covers change and inventory management, common safety and environmental procedures, and scripting basics, all core A+220-1202 skills. By the end of this module, you'll be able to implement best practice documentation to track assets, use common safety and environmental procedures, and explain basic scripting constructs and use cases. These three outcomes map to the lessons ahead. Lesson 22.1, Change and Inventory Management. This lesson maps to 2A plus 2201-202 objectives. 4.1, Implementing best practices for documentation and support systems information management. And 4.2, Applying change management procedures. By the end of this lesson, you should be able to answer, what is a change request? What purpose does a change advisory board serve? What is an asset? What information should be included in an asset inventory? And why must a technician understand the warranty process for a system? A change request is a formal proposal to modify a system, process, or configuration. Its purpose: document the reason for the change, an upgrade, a fix, a new feature, ensure evaluation before implementation, and provide traceability and accountability. An example: requesting a server OS update or adding new network hardware. The Change Advisory Board, or CAB, is a team that reviews and authorizes significant system changes. Its functions: evaluate the business impact and risk of proposed changes, balance cost, benefit, and timing, and approve, deny, or defer requests based on that analysis. Members typically include managers, technicians, security and operations staff, and other stakeholders. The goal: protect stability while supporting necessary improvements. An asset is any hardware, software, license, or resource owned and used by an organization. Types include physical assets, like computers, servers, and peripherals, and digital assets, like software licenses, virtual machines, and data files. Tracking assets supports inventory and lifecycle management, aids security and compliance audits, and reduces loss and unauthorized use. An asset inventory should include the asset's name and unique ID number, manufacturer, model and specifications, purchase and warranty dates, location and assigned user or department, and cost or depreciation if tracked. Tracking methods range from spreadsheets to a CMDB, configuration management database, or ticketing systems. The goal: accurate, updated records for auditing and support. Understanding the warranty process determines whether repairs are covered by the vendor and helps prevent accidentally voiding a warranty through unauthorized work, while ensuring proper documentation for service claims. Benefits: it saves time and money on repairs and supports asset lifecycle planning and compliance. For example, knowing a laptop is under a 3-year service contract prevents an unnecessary replacement. Here's what this lesson covers: change requests, risk analysis, change board approvals, implementation and acceptance, asset management, and warranty and licensing. A change request prevents downtime and disruption from configuration changes, ensuring all modifications are properly reviewed and documented. The process centers on a request for change, or RFC, form outlining the purpose and scope, the type of change, and the implementation schedule and potential impact, evaluated before approval or execution. Types of change: standard, routine and low risk, like patch installs; normal, reviewed and approved through a formal process; and emergency, implemented immediately to fix critical issues. Key factors: testing before deployment, accountability through documentation, and risk assessment. Here's what an actual request for change form looks like filled out. Notice the fields for purpose, scope, and implementation schedule that every change gets evaluated against. Risk analysis identifies potential risks before implementing a change, helping prevent downtime, data loss, and safety hazards. Key questions: will this change impact critical systems or users? Are there safety or compliance concerns? And what's the severity and likelihood of each risk? Mitigation strategies include preventative controls like backups and testing, following safety procedures during deployment, and analyzing cause and effect to predict outcomes. The goal: reduce the chance of failure and have recovery options ready before implementation. Risk scenario: hurricane. This poses a threat to assets and is classified as a natural disaster. Risk scenario: fire. This poses a risk to assets and facilities. This could also result in destruction of critical systems. Risk scenario: power instability. Lightning and surges can disrupt or damage equipment. Use UPS, uninterruptible power supplies. Damage to physical facilities from a vehicle accident could pose a threat to business operations. Insider threats are usually the most difficult to discover before anything actually happens. They could steal company data. Logic bombs are when an employee intentionally sets a trap that will run malicious code in the event of their absence. Minor changes get approved directly by a supervisor or manager, typically low risk and routine, like a printer driver update. Major changes require review by the Change Advisory Board before implementation. Think network redesigns, critical server upgrades, or system migrations. The CAB reviews the business case, technical risks, and impact on users and systems, ensuring changes align with organizational goals and compliance standards. Stakeholders involved include representatives from IT, operations, management, and affected departments. Here's what an actual CAB meeting record looks like. Notice the business case, the risk assessment, and the final approval decision, all documented together. Time for a simulation. Change management. Your team needs to upgrade the operating system on 50 workstations in a critical department. Draft a change request form, conduct a risk analysis, simulate a CAB meeting, and plan the implementation, including rollback and end-user acceptance. Execution means approved changes get implemented following a structured plan, including scheduled downtime, testing, and documentation of each step. Peer review has another technician verify the accuracy and completeness of the work, ensuring configurations, permissions, and security settings are correct before restoring service. A rollback plan provides a backup and recovery process in case the change fails, including snapshot or image backups, restore points, and contingency steps. End-user acceptance confirms the system functions as expected, documenting satisfaction before closing the ticket. Here's what a completed rollback plan actually looks like. Notice the specific steps to undo the change and the backup data it points back to if something goes wrong. Asset management ensures accurate tracking of all physical and digital assets, providing visibility into hardware, software, and resource allocation, and reducing loss, duplication, and unapproved use. Key inventory details: asset name and ID, manufacturer and specs, purchase date, warranty and cost, and the assigned user or department. Tracking methods range from spreadsheets for small-scale tracking to a CMDB for larger organizations. Lifecycle management tracks assets from procurement to disposal. Software licensing maintains legal compliance with vendor agreements, preventing overuse, piracy, or expired licenses. For hardware, keep the invoice, warranty, and support details along with contact information. For software, record licensing details, user or device allocations, and any usage limits. Both categories need to stay current and accessible for audits and support requests. Lesson 22.2: Common Safety and Environmental Procedures. This lesson maps to 2A plus 2201-202 objectives, 4.4 using common safety procedures, and 4.5 summarizing environmental impacts and local environmental controls. By the end of this lesson, you should be able to answer: why is electrical safety important? What purpose do fuses and grounding straps serve? What precautions should be taken with hazardous materials? And what causes ESD, and how can it be minimized? Electrical safety prevents injury, fire, or equipment damage from electrical hazards, protecting technicians working with live circuits, power supplies, or outlets, and ensuring compliance with OSHA and local building codes. Key practices: disconnect power before servicing, use insulated tools and test voltage before touching components, and maintain dry hands in work areas. Fuses protect circuits from overcurrent or short circuits, automatically breaking the circuit when electrical flow exceeds safe limits. Grounding straps provide a safe path for static or excess electrical energy, preventing shocks to technicians and protecting sensitive components, essential during PC maintenance and hardware replacement. Together, they ensure both personnel safety and device protection from electrical damage. Hazards include toner, batteries, cleaning solvents, and coolants. Precautions: wear PPE like gloves, goggles, and masks. Review the material safety datasheet before handling chemicals, store materials in approved containers, and dispose of them through certified recycling programs, and avoid inhalation, ingestion, or skin contact. The goal: protect technicians and the environment from chemical exposure or contamination. Here's what an actual MSDS document looks like. Notice the handling instructions and disposal guidance you'd reference before working with any hazardous material. Electrostatic discharge, or ESD, happens when static electricity builds up and discharges into components, common when technicians touch sensitive parts without grounding. It can destroy circuits or microchips instantly, even without visible signs. Prevention: use anti-static wrist straps and mats, keep humidity around 40 to 60%, avoid wool or synthetic fabrics in work areas, and handle components by their edges, not their contacts. The result: minimized risk of component failure and longer hardware lifespan. Here's what this lesson covers: compliance with regulations, electrical safety, and other general safety hazard mitigations. Continuing the roadmap: environmental impacts, electrostatic discharge mitigation, building power issues and mitigations, and materials handling and responsible disposal round out this lesson. Compliance ensures safe and lawful PC maintenance in all work environments, promoting adherence to occupational safety, environmental, and building codes. Key areas: health and safety standards, following OSHA and local regulations, environmental regulations, disposing of hazardous materials per state and federal law, and building codes, maintaining proper ventilation and electrical safety. Employee responsibilities. Use tools as intended, report hazards immediately, and avoid unauthorized installations. The outcome: a safe, compliant workplace protecting both employees and the organization. Understand the relationship between current, voltage, and resistance, and recognize that improper handling can cause shock, fire, or component damage. For protection, use insulated tools and voltage testers before touching circuits, and ensure proper grounding. Always disconnect power before servicing, and never open a power supply unit. There's risk of stored charge even when unplugged. For fire safety, keep CO2 or dry chemical extinguishers nearby and know where power shutoff switches are. Place systems in secure, ventilated areas near accessible power, avoiding blocked ventilation or stacked cords. For trip hazards, keep cables secured and out of walkways. Avoid running cords under carpets or across doorways, and maintain clear, stable workspaces. For lifting safety, use proper body mechanics, lifting with your legs, get assistance for heavy or awkward objects, and use carts or lifting tools when available. For protective gear, wear gloves, goggles, and masks when handling hazardous or dusty materials. Use ear protection in noisy environments, and make sure PPE fits properly. The goal: reduce physical injuries and maintain a safe, efficient workspace. Tripping and lifting hazards can pose a threat to employees and possibly equipment. Use compressed air or PC vacuums to remove dust buildup, wearing protective gear to avoid inhaling dust or toner, and clean carefully to prevent contamination. For temperature and humidity, maintain good ventilation, avoid direct heat sources, and keep humidity around 40 to 60% to reduce static and condensation, preventing overheating with proper airflow. For new equipment, let cold or sealed hardware acclimate to room temperature before powering on, preventing moisture condensation that can short-circuit internal components. Here's what a properly set up ESD workstation actually looks like. Notice the grounding mat and wrist strap working together to keep static discharge away from sensitive components. Common power problems. A surge or spike is a sudden voltage increase that can damage power supplies or components. A brownout is a temporary voltage drop from high demand that can cause instability, and a blackout is total power loss that can corrupt data or interrupt operations. Protection methods. Surge suppressors filter excess voltage spikes, and a UPS prevents data loss and allows safe shutdown during outages, offering temporary power from an internal battery. Proper sizing follows the formula VA equals wattage times 1.67, with runtime depending on battery capacity. Here's what an actual UPS unit looks like connected in a server room. Notice how it sits between the wall outlet and the critical equipment, ready to bridge any power interruption. Material safety datasheets provide safety, handling, and disposal guidelines for hazardous materials and must be accessible to all technicians. Personal protection means gloves, goggles, and masks when handling toner, batteries, solvents, or cleaning agents, preventing skin contact, inhalation, or ingestion. For proper disposal, recycle batteries at certified collection centers, never in regular trash. Return toner cartridges through vendor recycling programs, avoiding airborne dust, and dispose of electronics, which contain lead and other toxins, through certified e-waste facilities. Lesson 22.3. Scripting Basics. This lesson maps to A+2201-202, Objective 4.8, identifying the basics of scripting. By the end of this lesson, you should be able to answer: what is a script? What are the common scripting languages and file types? And what are some examples of tasks that can be completed using a script? A script is a text file containing a sequence of commands or instructions that a computer executes automatically. Scripts are interpreted, not compiled, meaning they run line by line through a scripting engine like Bash, PowerShell, or Python. Their purpose: automate repetitive tasks, perform system operations quickly and consistently, and reduce human error while improving workflow efficiency. Examples: automating backups, renaming files, or monitoring system health. Shell scripts, used on Linux and Mac OS, use the .sh file type, made executable with chmod plus x script.sh, and run with /script.sh. On Windows, PowerShell uses PS1 files with cmd-lets for system automation. Batch files use .bat for simple command line automation, and VBScript, a legacy format, uses .vbs run through WScript or CScript. Cross-platform, JavaScript.js handles web-based automation, while Python, .py or .pyw is general purpose and widely used for IT and data tasks. Here's what each of these scripting environments actually looks like running. Notice the syntax differences between a shell script, a PowerShell cmd-let, and a Python script, even though they're all accomplishing similar automation tasks. System administration tasks include automating software updates or user account creation, and managing files, logs, and backups. Network and security tasks include checking connectivity, monitoring performance, and scanning for unauthorized access. Application and web tasks include automating data entry or form submissions, and running server maintenance or scheduled cleanup. One example: a PowerShell script that creates user folders, assigns permissions, and sets up default configurations automatically. Here's a visual roadmap of what this lesson covers: shell scripts, basic constructs, Windows scripts, JavaScript and Python, use cases, and best practices. Here's what this lesson covers in text: shell scripts, basic script constructs, Windows scripts, JavaScript and Python, use cases for scripting, and scripting best practices and considerations. Shell scripts are text files containing command line instructions executed by a shell, like Bash or ZSH on Linux and Mac OS, used to automate repetitive tasks, manage systems, and configure environments. File type is .sh. Make it executable with chmod plus xscript.sh, then run it with ./script.sh. Best practices include comments with hash to explain steps, always test in a safe environment before deploying, and avoid infinite loops or destructive commands like rm-rf. Common use cases: automating backups, managing users and permissions, and handling system updates or log rotation. Syntax needs the correct structure. Errors stop execution entirely. Comments marked with hash add notes the interpreter ignores. Variables store and change values. For example, setting name equal to Alex and then echoing $name, or using $1 and $2 for input arguments. Control flow: if, for while, until, handles logic and repetition. Operators like equals, and handle comparison and logic. Best practices: avoid infinite loops, initialize and handle variables properly, and always test before deploying. PowerShell is modern Windows scripting using PS1 files, with CMD lets in verb-noun format like getProcess or setDate, running in PowerShell ISE or the terminal, ideal for system automation and administrative tasks. VBScript is legacy Windows scripting using .vbs, run with wscript.exe or cscript.exe, often found in older login or maintenance scripts. Batch files handle simple command line automation with .bat, using classic CMD syntax for tasks like launching apps, deleting files, or setting variables. JavaScript is a web scripting language using .js, running in browsers, servers via Node.js, or desktop apps. Common uses include form validation, web automation, and API interaction. Python is general-purpose scripting using .py or .pyw, run via interpreter or compiled as an executable, ideal for automation, data processing, and system scripts. Python 3 is the current standard, since Python 2 reached end of life in 2020, offering cleaner syntax and better library support. Here's a visual summary of scripting use cases. Notice how the same core idea, automating a repetitive task, shows up across system administration, networking, and application workflows alike. Time for a challenge. Scripting. Choose a scripting language: Bash, PowerShell, or Python. Write a script to create directories for 3 users and assign read/write permissions to each user for their own directory. Then test the script in a simulated environment. Malware risks. Restrict script permissions and user access. Scan scripts for vulnerabilities before deployment, and use least privilege principles when running scripts. System risks. Test scripts in a controlled environment first. Keep baseline configurations updated and documented, and avoid changes that create security or stability gaps. Resource mishandling. Prevent infinite loops and runaway processes, manage memory, disk, and network usage carefully, and monitor scripts during execution for unexpected behavior. Here's what script monitoring actually looks like during execution. Notice the resource usage tracked in real time, exactly what catches a runaway process before it becomes a bigger problem. To wrap up Module 22, using best practices for documenting assets ensures consistency, organization, and good management. Common safety and environmental procedures are essential for maintaining compliance with local and international laws and regulations. And scripting creates consistency in workflow, fewer mistakes, and greater efficiency in task completion. And that's a wrap on Module 22. Change and inventory management, safety and environmental procedures, and scripting basics, all core skills for keeping IT operations running safely and efficiently.